Operator overloading is fundamental to C++. In the last lesson, we discussed operator overloading with member functions. In this movie, we'll look at why and how you may sometimes use non-member functions for operator overloading. Here I have a working copy of rational.cpp from chapter 4 of the exercise files. And in the previous movie on operator overloading, we discussed overloading the 4 basic arithmetic operators with member functions. There's an important circumstance where this just doesn't work, and let's take a look at it. If we come down here to our main function, and I'm just going to add a line here, I'm just going to say a plus 14. Now, when I build and run, you'll notice that this works fine. Oh, I need to change this so we can see what it is here. See, 7 over 1 plus 14 equals 21 over 1, and that's the result that we would expect. If we turn this around and we say 14 plus a instead, you notice that I get an error here. And I'm just going to go ahead and I'm going to change this too, because we're going to make this work. But my error, if I click on it, it says invalid operands to binary expression int and rational. And so what this is doing is it's trying to add our rational number to a literal integer. And the literal integer doesn't have an overloaded plus operator that works with a rational object. It worked the other way around when I said a plus 14, because 14 is effectively a valid rational number because of our implicit constructor. And so you remember that if I don't include this second parameter, it defaults to a 1 for our denominator, and then it'll do an implicit conversion of an integer for a rational number constructor. And so this works because our plus operator takes a rational number, and that's just being created on the fly with the implicit conversion. The other way around does not work, because this is not using our overloaded operator. Our overloaded operator only works when a rational object is on the left-hand side. And the reason for that is because this is a member function. And so it's only taking one operand for the right-hand side, and it only works when the left-hand side is a rational number. So the solution to this is to use a non-member function for the overload rather than a member function. I'm going to show you how to do this. So I'm going to just take this plus one, and we'll do it to this. I'm going to take this out of our function definition. I'm going to take this function, and I'm going to cut and paste and put it above our overload for the left shift operator. And now I'm going to make this a non-member function. And so I'm going to take this rational colon out, and I'm going to make a constant rational ampersand left-hand side. And this is no longer valid because it's not a member function, so it doesn't need to be constant safe. Well, it'll be automatically constant safe because it's taking 2 constant operands. And now we need to change this. We need to put in left-hand side dot n for that one. I'm just going to copy and paste that left-hand side dot for all the places where we were using the data member. And we can't actually use the dot underscore n anymore because that's a private variable. And so you see that's private up there, and so we can't actually use it. So we need to use our accessors. Remember, our accessors are numerator and denominator, all spelled out. So this is just going to get a little bit long. I'm going to say numerator with the function operator there. That uses the member function, the getter for the numerator. I'm just going to copy and paste that everywhere we have the underscore n. And then I'm going to use denominator for all of these places. I'll copy and paste that, rid of that underscore. And now we have a valid non-member overload for the plus operator. And now when I save and run this, you notice we have the 14 on the left-hand side here. Now when I save and run this, we get 14 plus 7 over 1 equals 21 over 1. So we've created a non-member function for our operator overload for plus, and now it works both ways. So looking at this again, our operator overload now has 2 parameters. It has a rational number on the left and a rational number on the right. And so it'll work also in this case here with 2 rational numbers. That is being called, and we can put in a printf here to show you that. And when I build and run, you can see non-member overload is getting called there, and it's also getting called here in the places where we have the plus. So LHS, of course, stands for left-hand side, and RHS stands for right-hand side, and those are very, very common parameter names for the two sides of the operator. And this works because, again, the implicit constructor is working for the literal number even on the left-hand side now. So this is a very common circumstance, and this is why more often than not, you'll actually see non-member overloads for the arithmetic operators. So in a nutshell, whenever you have a constructor that allows implicit conversions, you really want to think about non-member overload functions instead of member overload functions. These functions, of course, should still go in your implementation file.